Hello students, welcome to the physics session. In today's session we will be discussing a combination of resistors and few numericals based on combination of resistors. Okay, let us start the session at 8:30 p.m. Be ready everyone, let us meet at 8:30. Okay, take care everyone till then. Good evening everyone. So in the last class we have discussed about combination of resistors, right? So let us start from the combination basics. So write out the heading of the chapter. What is the chapter we are doing? Current, electricity. Current, electricity. This. So we are discussing about combination of resistors. We are discussing about combination of resistors. Combination of resistors. So here we come across usually three types of combinations. What are they? Series combination, parallel combination, and mixed combination, mixed grouping of resistors. So in the first one, we'll see quickly and briefly is series combination of resistors. Series combination or series grouping of resistors. Series combination of resistors. Right. In this series combination, so the resistors will be connected from end to end so that same current will pass through each and every resistor. Same current will pass through each and every resistor. So this kind of combination is called series combination. So to understand this, let us just start with the combination of two simple resistors. Then we can extend this to n number of resistors. Okay? Right. Let us consider here we have still getting some noise. First, generate everyone. Right. Let us consider two resistors of resistances R1 and R2 which are connected in series and then to the source of EMF called as battery of potential difference V volts. Okay? So the current I will be drawn from the battery. This current will same current will passes through each and every resistor. So you can say this current I comes here, the same current will passes through both the resistors. This kind of combination is called series combination. Is it clear? Right. Then a battery is connected to two resistors in series. The potential of the battery will be dropped across these two. The potential drop across this, according to Ohm's law, is given by current through it into its resistance. So it is represented as V1. V1 is equal to I into R1. And potential drop across the second resistor is given by V2. It is nothing but I into R2. Got it? So, but why we need actually this combination of resistors, whether it is series or parallel, is in electrical circuits. Here we are considering just a simple case as two resistors combination. If you have n number of resistors, 100 or 200 resistors in a given circuit, it may occupy large space, so much space in the circuit. To save the space in the circuit, we remove all these resistors and we will remove with or we will replace with a single resistor. We call it as equivalent resistor. We call it as equivalent resistor. So that equivalent resistor resistance in series combination will be represented as RS. If you get that single resistor with the same battery, it plays the same role as the combination of these resistors. That is, if a current I is drawn from this and it is passing through this, then it gives the same potential. The potential drop across this resistor is equal to the total potential drop across the combination of resistors. Means V is equal to sum of these potentials. V is equal to I into Rs. Is it clear? So from there, by making use of this relation, let us try to understand how to find the equivalent resistance of series combination. So to understand that, we have to consider which parameter is dividing. As the same current is passing through both the resistors, but V is dividing into V1 and V2. So V is equal to V1 plus V2. So from this we can say V is equal to V1 plus V2. But from Ohm's law, here V is potential drop across this equivalent resistor. This V is equal to potential drop across the individual resistors. This is the equivalent resistance of all these individual resistors. So from Ohm's law we can say, from S, write down simultaneously, from Ohm's law, you can say V is equal to I into Rs and V1 is equal to I R1 and V2 is equal to I R2. We say this is equation 1 and these all together as equation 2. Substitute this in 1 or from 1 and 2 we can write 1 and 2 implies V is IRS. IRS is equal to V1 is I1 R IR1 plus V2 is IR2. So as I is common on both right hand side and left hand side, both sides. So if you can take it here common, you can cancel it out. So hence we get the effective resistance of series combination is equal to sum of the individual resistances. If you have two resistors, instead of 2, if you have n number of resistors, you can say that equivalent resistance is equal to sum of all the resistances. So that you can write as the next extension part. So first note down this, then we will see the next point. Copy fast we gave. Completed already. Right. So if you extend this for n number of resistors, for n resistors, we can say that Rs is equal to R1 plus R2 plus so on plus Rn. This already we have discussed in the previous session. If you are absent in the previous session, you can note down, otherwise it is there already in your notes. Okay? See here. Right. So this gives you, let's look here. This gives you effective resistance of R series resistor. Combination of n number of resistors connected in series. So here we will discuss few more simple points or special points which states that if all of these resistors are identical, means are having same resistance, that is if R1 equal to R2 equal to R3 equal to so on equal to R, or you can say simply for n identical For unidentical resistors, and write the series combination, effective resistance of series combination RS, or you can say R effective is equal to R plus R plus R plus so on up to n times. So you can write this as n into R. If you have n number of resistors in series combination, that can be 2 or 3 or 10 or 100, any number. Is it clear, everyone? Right. Yes, this is general one, general case. This is specifically in case of identical resistors, n number of identical resistors. Okay? Right. Next, we'll see parallel combination of resistors. Here you can also write one note that if you have n number of resistors, effective resistance or equivalent resistance, you can also call it as equivalent resistance of series combination, should always be greater than the largest value of the resistors, individual resistors, or greater than the greatest value. If you have 3 resistors, 1 ohm, 2 ohm, 3 ohm, the total is 1 plus 2 plus 3 is 6 ohm. So it is greater than the largest one. What is the largest out of 1 and 3? 3. So 6 is greater than the largest one, right? So we can say in series combination, effective resistance will be greater than the greatest one in the combination. Okay? So the RS will be greater than greatest one in the combination. This is briefly few points about series combination. While doing the numericals, you can understand the different ways of attempting this. Next, write down parallel combination of resistors. Parallel combination of resistors. Right. Okay guys, next. Okay, fine. Parallel combination of resistors. Parallel combination of resistors. Right. So when resistors are said to be connected in parallel, when they are said to be connected in series, if the resistors are connected end to end, so that if same current passes through every resistor, then they are said to be in series. Whereas if the resistors are connected in such a way that if one end or first end of all resistors are connected at one point, if you have n number of resistors, then the first end or first terminal of all resistors are connected at one point, second end of all resistors are connected at another point, and these are further connected to the terminals of the cell when this occurs, so that same EMF will drop across all resistors. The such combination is called parallel combination. That is, if you connect this to the cell or a battery of potential difference V volts, then current I will be dropped, will be derived from this. The current I will be drawn from the cell. This current I divides here as I1 and I2. Got it? So I divides into I1 and I2. This is R1, this is R2. Then this current combines together and gives the complete what you call closed loop of the circuit. Here, if you replace this with a single identical resistor, because as effective resistance of parallel combination, and if you connect this to the same battery, you connect this to same battery of potential difference V volts, so that if current I is passing through this, then it gives the similar effects as that of this combination of resistors. Got it? This kind of combination is called parallel combination of resistors. Okay? So, in parallel combination, as current divides, so I can say that in series combination potential divided. So I have taken V is equal to V1 plus V2, and by making use of that relation, I have obtained an expression for effective resistance in series combination. Here what divides? The parameter which is dividing is current. So by taking this into consideration, you can write I is equal to I1 plus I2. I is equal to I1 plus I2. Again, we say this is equation 1 from Ohm's law. From Ohm's law, you can say as I is equal to V by R. In the equivalent circuit, I is equal to V by RP. Here this I of an equivalent circuit is V by RP, and I1 in this is I equivalent to that I. So I1 is V by R1 and I2 is V by R2. If you substitute these values in one, then one can be expressed as V by Rp is equal to V by R1 plus V by R2. And simplifying this further, we write 1 by Rp is equal to 1 by R1 plus 1 by R2. This gives effective resistance in parallel combination. This further you can also simplify and you can write this as like Rp is equal to cross multiply, you get R1 plus R2 by R1 R2. The reverses, take the reciprocal, you get R1 R2 divided by total resistance R1 plus R2. This gives effective resistance in parallel combination of two resistors. So whereas if you have n number of resistors, so instead of writing this you can make use to write the effective resistance of parallel combination. So here you can write for n resistors. For n resistors means for n different resistors, or for n resistors of different resistances, you can write 1 by Rp is equal to 1 by R1 plus 1 by R2 plus so on plus 1 by Rn you can take. Again, just like in the previous case, here, if all these resistors are identical, means R1 equal to R, R2 equal to R, R3 equal to R, if n number of resistors there, all are identical and same value. In such case, it is for n identical resistors. Identical resistors. Write 1 by Rp is equal to 1 by R plus 1 by R plus 1 by R plus 1, how many times? N times. So they write 1 by R into N, or N by R will get. 1 by Rp is equal to N by R, or can write Rp is equal to R by N. Rp is equal to R by N. If two resistors are there identical, then R by 2, 3, R by 3, 10, R by 10, like that. Is it clear? This gives the effective resistance of parallel combination of resistors. Again here you can observe that Rp is R by N, R means 1 by Rp equal to what is called sum of reciprocals of individual resistances. If you observe here, the Rp effective resistance of parallel combination should be less than the least one. If you have two resistors, 2 ohm and 3 ohm, least one is 2 ohm. So effective resistance will be less than the 2 ohm. That is what you can observe from this. If you have 2 ohm and 2 ohm, so effective will be 2 by 2, 1. So it is less than 2. Less than 2 ohm. Is it clear? 3 ohm and 3 ohm. So effective resistance will be 3 by 2. 3 by 2 is 1.5. So it is less than 3 ohm. That's what you can understand. So you can write and conclude the point that in parallel combination, Rp will be less than the least one in the combination. Rp will be less than the least one in the combination. Less than the least one in the combination. Right? Fine. This is briefly about series and parallel combinations. Now, let us see mixed combination of resistors, not separately like theory here. With the help of some examples, we will work out. Let us do some numerical, important numericals and a few previous years based questions also. These are very important guys. Try to practice everyone. Before that, I would like to give you two shortcut formulae. Whenever it is required, while simplifying the questions, you have to make use of those. So let us do those. Can I erase this now? Everyone? Right. Yeah. See, I'll give you two simple relations. That is, first one is if you have two resistors R1 and R2 are connected in series to a cell of potential difference or EMF V volts. You following everyone? Then the current I is drawn from this and this current I is flowing to this, so that the V1 potential will drop here, V2 will drop here. Similarly, the second point is if you have two resistors connected in parallel, and this combination is connected to a cell or a battery of EMF or potential difference V volts. So that here the current I is drawn, that current I is dividing into I1 and I2. This is, let us say, R1, R2. Following this everyone? Now, here what is dividing? Current is same, potential is dividing. Here in parallel combination, potential across both the resistors will be same. Got it? But what is dividing here? Current is dividing. In series, potential divides. In parallel, current divides. So by using this potential divider principle and current divider principle, we come across two simple relations. So that is V1 is nothing but IR1. Are following? But if I is not given, then how to find V1? By V is given. R1, R2 are given. Then how to find? So to find this, first you have to find out the total current in the circuit. So according to Ohm's law, V1 is equal to what? IR1. Yes or no? IR1. So V1 is equal to IR1. Right? But from Ohm's law only, you can say current in a circuit. Remember that current in a circuit usually is equal to net EMF by total resistance. The net EMF is nothing but V by total resistance is R1 plus R2. So you can write there I is equal to V by R1 plus R2. Is it clear everyone? Yes or no? So these two resistors are in series. So I is equal to V by total resistance. Total resistance is R1 plus R2. So if you replace this here, you can get I is nothing but V by this, or you can write V1 is R1 by R1 plus R2 into V. This is V1. V1 is R1 by R1 plus R2 into V. Whereas V2 is R2 is equal to R2 by R1 plus R2 into V. So that is how we can get simply directly can calculate V1 V2 without any further calculations by remembering these relations. We call them as we can remember this as a shortcut relations. By using potential divider principles, you can calculate V1 V2 directly by remembering this formulae. Similarly, here by using current divider principle, what principle? Current divider principle. Here, potential across this is nothing but I1 R1. Here it is I2 R2. They are equal. They are equal. Potentials are equal. So by using this potential divider principle, you can say again here the current in this branch, that is current through first resistor, is given by I1 is equal to. Just remember that current in this is equal to this resistor equal to the other resistor. So this is applicable only when two resistors are there. Okay. The other resistor by other resistance by total resistance into total current. The total current will be given. Is it clear, everyone? So it can be expressed as I1 is equal to what? R2 by R1 plus R2 into I2. In terms of without using V, you can find out this. Similarly, I2 is equal to I2 current in R2, that is equal to the other resistance, that is R1 by total resistance. R1 by R1 plus R2 into total current. So the ratio of this can be also obtained, but you can find out depending on the questions. You can calculate I1, I2 values or their ratios, etc. Similarly here also. These you can remember as shortcuts. Series by using potential divider principle, V1 V2 can be obtained like this. In parallel, by using current divider principle, you can find out I1 I2 by using this. Got it? Right. Next. So let us do a few questions. I will give you a few simple questions first. Based on the combination of resistors. Based on combination of resistors. What kind of questions you may come across? Let us see. Okay. So first, let us see one simple example. Right? Can I erase this? Everyone? Next, write down. Write the question. This question is common for all the questions. The question is find effective resistance between A and B in figures shown below. This is the common question for all the questions which we are going to work out now. The first one is we have a resistor R and we have two more resistors R and R. These are identical resistors. They are connected like this. And this point is connected to terminal A. This end of the wire is connected to terminal B. Between these 2 points, what is the effective resistance is the question. So, what is your answer? I am not giving you the options. Direct answer you have to tell me. I am not giving you the options. What is RAB? What is RAB? RAB is equal to what? So, we have to first reduce the circuit at some point. See here, these two resistors in parallel. Yes or no? These two we have to reduce into one resistor first. So, you can write down here. The question is, what is RAB? Okay. So, how can you draw this is further? This is A. So, So here R is there, then these two reduce to one resistor. So what will you get? What will you get? Z is point B. So these two are identical resistors in parallel. How many? 2. So in case of a parallel combination, what is RP? R by N. If the n number of identical resistors are there, here number of resistors are 2. So R by 2. So this is nothing but R by 2. Is it clear? Directly R by 2. So this and this are said to be in series. How can you consider that? Whenever you are asked to find the distance between 2 points, you have to consider an imaginary battery between these. So if you connect higher potential to this and lower potential to this, okay? So current is supposed to pass like this here, then it divides here. So and they combine and they come out here. So as it is dividing here, these two are said to be in parallel. So I have reduced it by using parallel combination. Now whatever current is passing through this here, the same current is passing through this. So these two are said to be in series. So what is the electrical resistance of these two? R plus R by 2 is how much? That's it. So RAB is equal to R plus R by 2 is equal to 3R, right? Is it clear, everyone? Very simple circuit. Very simple circuit. Next. Second question. Same. Question is same for all. What is that? Find the vector resistance between A and B in the figure. Between A and B in the figure. The figure is C is the figure. C. I think we have. Did we discuss about direct current resistors? Yes. Okay. See here. This is point A. The wire is connected here and here. The resistors are connected in such a way that one resistor is here and here another resistor is here, and these two are connected to terminal B. And this forms kind of a rectangle or what we call square. So along the diagonals here, 2 more resistors are connected like this, and in this diagonal 2 more resistors are connected like this. And it is given that all are identical resistors, and this is triple R, this is triple R. So all R's are equal to 12 ohm each. Okay? So what is effective resistance? So what you have to understand is you have to imagine, remember how to solve. You have to imagine a battery between A and B. So imaginary battery between A and B. So that current will pass from so that you have to consider higher potential. This is lower potential. Higher potential should be connected to the first point always. Okay. Then as current is passing like this, after coming here, the current, let us say this is I, divides into two parts. Let us say I1 and I2. Is this okay? For understanding purpose I am giving you this. Once this current comes here, this divides further into this I2. So I3 and I4. And this here, this divides into I5 and I6. Is it clear? Now, at the other end, you just immediately have to go to the other end. You have to observe that once this current divides into I1, I2, and this here divides and this here divides, so that these will combine, go through some different ways, and they have to come here, and this has to come here as something like I1 should come here as I1 only, I2 should come here as I2 only, and this will combine and go as I. Is that part clear? This is the logic we have to use while dealing with this kind of issues. So, when I1 divides into I3, I4, and it is given as I1 means I3 should come as it is here, and I4 should come as it is here. I3 and I4, and they should combine and it should give I1. Okay? Okay? That means this I4 is going like this, is not dividing here. That means this circuit acts like not in contact with this. So this also acts like not in contact with that. So that means here I2 is coming as this means I6 will come here as this, I5 should come as this. So that means there should be no contact. This kind of symmetry relations we have to use. Symmetry relations we have to use. So now you can understand that this resistor, these two resistors, here whatever current comes here it is passing through this means these two are inside series. Yes, that means you have to reduce these two into one resistor. That resistor and this will be in parallel. Reduce again further. Similarly, these two are in series. The resultant one and this will be in parallel. Reduce those two into one. So like that is those resultant one, this resultant one will be in parallel. That will give you the effective resistance. So this you have to do very quickly. As I am explaining now, I am telling step by step. I am explaining. So I may take 10 minutes to explain this. But you have to do it within 1 minute. For that you have to practice. Okay? If you are talking something without listening, you will not understand anything. Even after 1 year also it will be like that only. It will appear like so complex one. If you are listening carefully, write down and practice, then it will be very simple. Right? So I am reducing the circuit. I am redrawing this as this part. I would like to write this as this is R. These two will become 2R. 2R. S. This is R. This is R. R. This is 2R. Similarly, this is R. And these two can be replaced with 2R. And these are joined here. Then 2R and 2R in parallel. R and 2R in parallel. So what is the effective combination of R and 2R? Parallel combination. R1 R2 by R1 plus R2. You have to do it. If you do, you will get R into 2R by R plus 2R. How much? It becomes 3R. So R into 2R. 2R square. 2R square by 3R. R cancel. 2 by 3R. 2 by 3R. 2R by 3. So this will be 2R by 3. This also will be 2R by 3. These are in parallel. Again. Yes. These are in parallel. So R1 is 2R by 3. R2 also 2R by 3. So it's identical resistors, right? Identical resistors. R. The same is this is entire thing is R. Small r. This is small r. Or I can take this x. Some x. This also some x. So parallel. So x by 2 is effective resistance. But that x is nothing but 2R by 3 by 2. So what will you get? So this is A. This is B. So RAB is equal to 2R by 3 by 2. R 2R by 3 into 2. 2 cancel is R by 3 is effective resistance. Is it clear everyone? So this is how we have to work out. So after working out it becomes complex. While working step by step you have to follow, you have to write and you have to practice. Do it fast. This you have to do the reduction part, reduction mechanism step by step. So if you do that it will take so many steps. So that's why I am reducing the steps and giving you in short. Because already you guys know it. I am just trying to recollect back. Next. Should we say? Next question. Right. Another simple question. Which one? Third one. Third question. Again, find the effective resistance between A and B in the figure. So here the figure is this. We have this is terminal A. We have 3 resistors 1, 2, 3, and here also this is terminal B. Here also we have 3 resistors. 1, 2, 3, and these are connected like this. Oh, these are connected by another resistor here. So these all are identical, and in between these two, one resistor is connected, here another resistor is connected. All are identical. R, and here triple R, and here triple R. Okay? Your favorite triple R. So, what is the total resistance between, effective resistance between A and B? So there, the value of resistance is given as R is equal to 2 ohm. Take R is equal to 2 ohm. So what is RAB? What is RAB? RAB is equal to what? So you have to, in this kind of cases, you have to reduce the circuit from the end part. So let us say, imagine, what do you call it? An imaginary battery here. So a current comes here, this divide here. Okay? Yes. Then the current which is coming here, this comes here and divide here. Then whatever current goes here, the same current passes through these 3 resistors. Is that point clear? That means these 3 resistors are in series. So reduce all these 3 with one resistor. What will you get? R plus R plus R. How much? 3R. This is 3R. This 3R is in this is R. This 3R is in parallel with R. What will you get? 3R in parallel with R. R into 3R by R plus 3R. What is that? Wait. R into 3R by R plus 3R. It is 3R square by 4R. So 3 by 4 R. Is it clear? 3 by 4 R only. 3 by 4 R is again in series with this and this. So this is 3 by 4 R and in series with this also. So here R plus 3 by 4 R plus R. Don't need to do step by step here. Directly you can do it. Okay? So R plus R, 2R plus 3 by 4 R. 2R plus 3 by 4 R. How much? 4 2's, 8. 8 plus 3, 11. So 11 by 4 R. So till here. So till here, the entire resultant is how much? 11 by 4 R. So here, let us take this R. This is 11 by 4 R. 11 R by 4. The entire part of this. Now that is in parallel with R. So what is that? So 11 by 4 R into R by 11 by 4 R plus R. Do it. Right. So it can be replaced with the R, what? R, this is A, this is B. So this entire thing is 11 by 4 R. This entire thing is 11 by 4 R. 11 R by 4, this is R. These two are in parallel. Yes. What is the effective of these two? What is the effective of these two? R into 11 by 4 R by 11 by 4 R plus R. So plus 1 into R. So what is that? 11 plus 4, 15 by 4. So it is R cancel. So 11 by 4 into what is this? Here 15 by 4. 15 by 4. 4 cancel. So R is there. So you get 11 R by 15. 11 R by 15. So this can be further written as R. This is 1 R. This is R. These are R's. R. This is 11 R by 15. This is R between A and B. So sum of these, now that comes here, this simply goes here. So all these three are in series. So what is the effective value? So R plus R, 2R plus 3R by 15. So it is RAB is equal to 2R plus 11 by 15. R, so much? 13 plus 11. How much? 13 plus 11, 40, 1 by 15 R. These are it. Okay? So now I will give you one similar kind of question. Now only I have to do it within a minute. But the simplification will be a little simple. So that it will not take this much kind of 3 by 4, 11 by 15, this kind of fractions will not get. So simplified calculations will come across. So that kind of values I will give you. So can I erase this one? This one. Right. Next circuit is fourth one. So this is similar, but here 3 resistors are there, just like in previous case. Here also 3 are there, just like in previous case. Here 1 is there, and here 1, and here 1. Same, exactly same, guys. Exactly same. This is triple R. Okay. This is 222 ohm. And this is also 2 ohm, and it is given that this is also 2 ohm only, but these are 3 ohm each. Now this will simplify the calculation. So now without doing step by step, directly can do it. What is this total? What is the total? 2 plus 2 plus 2, 6. 6 in parallel with 3, how much? Read on the paper. 3 into 6 by 3 plus 6. 3 into 6 by 3 plus 6 is 9. 3 ones, 3 threes. 3 ones, 3 threes. How much will you get? 2. So, this entire thing will be replaced with 2 ohm. 2 ohm will come here. Is it clear? So now 2 are in series. Got it? So what is the effective of these 3? 6, and that 6 is in parallel with this again. Same. How much will you get till here? Till here? What will be this? 2, 3, and 6. The effective of these 3 will be 6. So 2 or 3 and 6 are in parallel. Again we get 2. So 2 will be series now. That is the final one. What is the effective resistance now? 6 ohm. Cut. Okay? Got it? Next. Oh, 9:30 now. Okay. Fine. I will start this now. You can practice few questions. I will give you one simple question that I will practice. You have to remember infinite ladder network based questions also. Infinite ladder network based questions. Let me do that. Then I will stop this. To find the selective resistance, there are so many methods are there. You have to remember all those guys. Some examples. So before infinite ladder, I will give you one more simple example here. Let us see. We have there are 2 resistors, and here one resistor is connected here, and this is connected in the form of what kind of circular structure. Okay, like this. So that this is A, this is connected here, and here one more resistor is connected here. So that this is 4, this is 4, this is 4, this is how much is this? The vector resistance between A and B is 3 ohm. So the value of this resistance is given as R. So the question here is, what is the resistance? What is the value of R? So that RAB is 3 ohm. If RAB is 3 ohm, what is R in the figure? What is R in the figure? So you have to use same method. What is that is? Here you have to imagine a battery. Okay, this is positive. So if it is connected here means this positive means this will be positive. When a connecting wire is there means this also will be positive. Means this is here positive potential here is same as this. Potential here also same as this. All parts will be at same potential A. And this is B potential. Here the potential can be different. Let us take it as X. Then you can mark like this. Potential A, potential B, and some point X. Between A and B, just like in capacitors. Just like in capacitors. Between A and B, how many resistors are there? Between A and X, how many are there? Between A and X, how many are there? 1, 4. So let us mark here. 1, 4. Done. Between A and X, 1 more 4. 1 more 4. Yes, done. Between A and B. Between A and B, this is A and B. This is R. Between B and X. B and X, 1 more 4 is there. So this is A and B. Is it clear? This is how we have to redraw it. After redrawing, this is 4, this is 4. They are in parallel. So reduce this to 1. So what do you get? 4 by 4 is, 4 by 2 is 2 ohm, right? 2 ohm. This 2 and this 4 will be in series. So 2 plus 4 is 6. And 6 is in parallel with R. So 6 into R by 6 plus R is equal to RAB. RAB is equal to 3. Is equal to RAB. RAB is equal to 3. Cross multiplying we get 6R is equal to 6 3s 18 plus 3R. So we bring this here, 6R minus 3R means 3R is equal to 18. So R is equal to 6 ohm. Like this you have to work out this kind of questions. Okay? Right. Another simple question is previous year question actually. It is asked in one of the exams. Simple question. So there is point A, there is point B. Here we have 3 resistors. 3 resistors. They are connected like this. Then it is also connected to 3 more resistors like this. This is a previous year question, guys. So what is these are 333, this is 666. What is RAB? RAB is equal to what? RAB is equal to what? Okay, infinite later network based questions we will do later. As time up, I will take some half an hour for other students. I am winding now. So what is this? What is this? How much? 1. 3 by 3. So it is 1. It is 6 by 3. 6 by R by N. How many are there? 3. So R is 6. 6 by 3 is 2. 6 by 3. 2. So this is in series. What is RAB? 1 plus 2. That's it. Okay? Right. Okay, I am winding this. You guys go through these kind of questions and practice yourself, the previous year's questions. If you have any doubts, we will discuss later.